Hi folks, Dr. P here. This is a question from the probability unit. This is from the PDF for the practice test for the probability unit, question 7, 8, 9. So in this question here, we have a diagram that shows the sample space S of 12 equally likely outcomes. And in question 7 here, they're asking us for the probability of the complement of M. So we can write that as the probability of the complement of M. So that means everything but M. So how many favorable outcomes do we have? Well, we're going to be counting all of the elements that are outside of M. We have 1, 2, 3, 4, 5 elements that are not part of M. So the number of favorable outcomes here are going to be 5 divided by the total number of outcomes, which is 12. So the correct answer for 7 is A. In question 8 here, now they're asking us for the probability of M or union, or I'm going to write union N. So remember that union means or. So the outcome, it can either be in set M or in set N or in both. So it basically means all of the outcomes that are within these two sets. So the total number of favorable outcomes is 11 divided by the total number of outcomes, which is 12. So the correct answer is A. In question 9, they're asking us for the probability of N given that M has occurred. So this here is called conditional probability. Okay, conditional probability, and it's read as probability of N occurring given that M has occurred. So to solve this question, to determine this, we are going to turn to this formula here, this is from lesson 4, the lesson 4 PDF in probability, and it's the multiplication law for dependent events. So what this law says is that the probability of A and, this is intersection, which means and, that will be the overlap. The probability of A and B occurring equals to the probability of A occurring times the probability of B occurring given that A has occurred. So in our context here, we're looking for the probability of N occurring given that M has occurred. We're going to just change the notation in that formula here, so it's a little bit easier to interpret. So it's going to be the probability of M occurring and N occurring, which equals to the probability of M occurring times the probability of N occurring given that M has occurred. So what we're able to do is we're able to determine what this is. Okay, so this is just the intersection, which is going to be the overlap here. There are two favorable outcomes in here, so it's going to be 2 over 12. We can also determine the probability of M occurring. So the number of outcomes in M are 1, 2, 3, 4, 5, 6, 7. So it's going to be 7 over 12. We just plug that in. So actually this here, I'm just going to erase this because I'm not going to need that here just yet. So I'm just going to erase that for now. And what we're going to do is we're going to just plug in these values into this formula. So we're going to get 2 over 12 equals 7 over 12 times the probability of N occurring given that M has occurred. We're solving this for the probability of N occurring given that M has occurred, and we're doing that by dividing both sides by 7 over 12. And if we do that, we're left with the probability of n occurring given that m has occurred equals to 2 over 12 divided by 7 over 12. And now we just have to evaluate the right hand side. Now, anytime we are dividing two quotients like this, or two fractions, the trick here, which I hope you remember, is that you're going to take the first quotient, just write it down the way it is. The division sign is replaced by a multiplication sign, and the second quotient, the second fraction here, is going to be reversed upside down, or we're going to take the reciprocal of it, which means that we're going to get 12 over 7. And now we can see that we can simplify this. This 12 here cancels this 12 here, which means that we're left with 2 over 7. So the correct answer for 9 is D. I hope that helps. Until next time, may the math be with you.